Okay, so this is another double integral, but you'll see there's going to be a hitch that we'll have to deal with. So if we just start to do it, this is the integral x equals 0 to 1. Then on the inside, we have the integral y equals x to 1 e to the y squared dy dx. Okay, now the next step should be to take the antiderivative of e to the y squared with respect to y. Now, this is a problem. This is a problem because we can't find the antiderivative of e to the y squared. Now, if we had a y there, notice if we had a y there, we could do u substitution or something, but we can't. But if we look at the limits, we notice that here, in the inner limit, y is in terms of x. Y is equal to x. So we hope maybe if we swap the order of integration, something will happen, and we can get we hope something will happen. We'll see. We hope something will happen that will get us a y there if we do a different order of integration. Because notice, like, if this was e to the x squared and we did this, then maybe we could get something. So let's go to Desmos and look at the region of integration and change the order of integration and see if we can get something to work. Okay, so this is what we're integrating. And when we look at the integral, y goes from x to 1. Okay, so the y integral is on the inside and it goes from x to 1. Okay, so now what we want to do is change the order of integration and do the x integral on the inside. So x is going to go from 0 to y. And now y is going to go from 0 to 1. And we're integrating e to the y squared dx dy. Now, as far as x is concerned, y is a constant. So the value of the inner integral is just y e to the y squared. And now this is a u substitution problem. So we can say u is equal to y squared, and du is equal to 2y dy. So y equals 0, u is equal to y squared. So this is going to be u equals 0 to 1. U is equal to y squared, y is equal to 1, so this stays 1. Then this will be e to the y squared du over 2y. These y's cancel, which is the whole point. So this is equal to the integral u is equal to 0 to 1. Y squared is u, that was the whole point there. So this is e to the u over 2 du. This is now a very basic Calc 1 integral. The antiderivative of e to the u is e to the u. So this is e minus 1. And so the value of the integral is e minus 1. But notice that we couldn't do this integral. It's not just that it's more convenient to do it with the x integral on the inside. We could not do this integral with the y integral on the inside because it requires that we know what the antiderivative of e to the y squared is. But we can't do that. So for this integral, we had to change the order.